National Weather Service meteorologist, and currently I'm a senior researcher, meteorologist, climatologist, paleoclimatologist, which means of the past, before recorded history, and you can take pictures of any slide you want. And we're going to be talking pretty much on what I call ClimatePulse technology. Everything is a climate pulse. God created this. And we're going to go over that. And this is just a little bit here on, I do hurricane landfall predictions, climate change, weather cycles. I have a ebook on the website. So we're going to take a walk through climate change. Father Don hit on some of this. On the first section is going to be kind of on what Father Don was talking about. Then we're going to go to section number 2, which hits completely on CO2 in the atmosphere, new research. And then we'll put it all together. As we know, they said 4 years ago, global warming, the world will end in 12 years. Now we're down to 8 years and counting. But this is the proof of the global warming. This is in 1860. And here we are today. So global warming is real. Climate change is real. There's no doubt about it. So we're going to talk about Earth's natural climate pulse, created by God. Well, humans and animals, we require a good night's sleep. If we don't get it, we don't do very well. Well, the Earth is the same way. It requires periods of complete rest, or it does not function well. And this is all tied into the Earth-Moon-Sun interactions. This is proven science, the Milankovitch cycles. You can get this, just Google it. And what it is for ice ages and what we're now interglacial warm period. Here is the sun, the earth, and we revolve around the sun. Every 120,000 years, we're the furthest distance from the sun. And during that 60, 80,000 year period, we're in a glacial period. And also it has to do with the tilt of the Earth on its axis. Then we come in closer to the sun. We hit this point about 7,000, 8,000 years ago, closest approach to the sun on a long-term basis. This is why 7,000, 8,000 years ago we warmed up into an interglacial period. This is all known science, but right now we're 7,000 years off of the peak. That's very important. So this is what it looks like in this is before recorded history, let's put it that way, is they take it from ice core samples. This is the temperatures going back almost 500,000 years. This is the warm interglacial period, 420,000 years ago. Then Earth goes into a pretty deep sleep, a long glacial period. Then we warm up, cool down, warm up, cool down. So we have warm periods and sleep periods. And here we are now. We just came out of the glacial periods about 8,000, 10,000 years ago, and we're right here. All natural cycles. And we also have smaller cycles. Those cycles were about every 120,000 years. We have smaller cycles at about 1,200 years. And this is 10,000 years ago. We came out of the Ice Age, warmed up. 7,000 years ago, we were very warm. Very warm. Warmer than today, much warmer than today. 50% less ice in the Arctic than today. And you don't hear about that in the news. Yeah. Then on the 1,200 year cycle, it cools down, warms up, cools down, warms up. And here we are over here. We're in a warm period, interglacial. Well, this is a global warming period. But you can see during the course of the last 7,000 years, we're cooling down, not warming up. It's opposite of what they're telling you. Well, humans also sometimes need an afternoon snooze. we get a little worn out during the day. So we take a rest. Well, the Earth also requires an afternoon nap at times. And what this is, now we take into play the moon, Earth, and the sun will appear here pretty soon. This is the moon, what we call the apogee, furthest distance from the Earth, and this has specific cycles. That's the weakest gravitational cycle of the Earth-Moon. And then, as it revolves around the Earth, it comes, and it's going to stop over here in a second, to a close approach. This close approach will come once a month, and more so stronger once every 4 years, 18 years, 72 years, 120 years. It has all kinds of cycles on it. Now, when we have a close approach, the gravitational pull increases by 30 to 40%. If it's in alignment, the Earth, Moon, Sun become in alignment, this is called a syzygy. Gravitational pull is increased by 44 to 47%. That's why sometimes you have coastal flooding without a storm, just because of the moon. So this kind of just depicts every 4 years the strongest gravitational cycle of the moon, Earth, Sun goes down to southern latitude, 4 years later up to the northern latitude. That's a 4-year cycle. Great tugging on the Earth's oceans and atmosphere. So much that the outer core of the Earth bulges by 1.5 kilometers during these strong cycles. That's why you can have increased earthquakes, volcanic activity. And all these cycles come out to, you have your 12-hour tides in the oceans, 72-year cycles in the weather, climate, 230-year cycle, that's what we're really going to home in on today. And that's just the gravitational envelope. And if it was not for the moon is so important. It keeps the Earth in its proper orbit around the sun. If the moon was to disappear, the Earth would go out of its orbit. That's how important it is. And they don't look at this in science. They don't tell you about it. And this is a depiction of the cycles. This is a 1,200-year cycle. Every 120 years or so, strong cycle, it goes like this. That's a course of 120 years, and actually the 18-year cycle looks the same. So it's a rhythm that goes all the way out to, really, out to 400,000 years. So this is our global warming cycles. We've had 6 of them during the past 1,100 years. Well, if you listen to the news, we've had one. One we're in now, that's it. But we have had 6 of them. And 1, 2, 3, 4, 5, 6. Now the gravitational cycles that I showed you, let's overlay them on the global warming cycles. That's what controls the global warming cycles, the gravitational cycles, not carbon dioxide in the atmosphere. And of importance is when we look at the global warming cycles, look at the one way back at 900 AD, when that global warming cycle ends, the next global warming cycle ended about 200 years later. The next one ended 230 years later, 240, 230, and here we are right now. The last one ended in 1794. If you take 1794, add 230 years to it, we come out to the year 2024. We're supposed to be going into a global cooling cycle. However, we're told that fossil fuel will eliminate the cycle. That's what they're trying to tell us. It will override the cycle. And will it? This is one thing we're really going to look at. And just a signal here, of the global warming, global cooling cycle. What a global warming cycle really is the North Pole and South Pole warms up every 230 years. It gets milder. And this has occurred since about the year, well, in the 1990s it started warming up. It takes 20, 25 years for it to hit its peak, and it just hit its peak. And when it warms up, you have less cold air, not as cold as you usually have, to come down into the mid-latitudes during the winter, so the mid-latitudes warm up. That's global warming. Global warming begins at the Arctic and Antarctic. Well, also, we have global cooling also begins at the poles. The poles get colder, and actually, well, the signal is the spring and summer in the Arctic of this year was the coldest on record. Did you see that in the news? No. Of course not. It's buried. Last year, 2021, the winter in the Antarctic, coldest on record. Did you see that in the news? Of course not. But you did, okay. It was in the news for about one day, then you couldn't find it. It was kind of buried on Google. So anyway, the poles start cooling down. That's what's happening now. So that ends up cooling down the mid-latitudes, and then the mid-latitudes will be colder, will be in global cooling. And this is in the process now of going into the global cooling. And I already told you about the cold period. So proof of global warming, that's what we saw. With the poles cooling down in Alaska and Canada and the northern states getting colder. Well, there's the proof that global cooling is coming. Okay, carbon dioxide and climate cycles. Extremely important. This is what they're all homing in on today.
Blow your socks off.
Well, when I looked at this data, it did. It blew my socks off. And hopefully it will yours to some degree. Now this gets a little bit more in depth, a little bit harder to follow, but I'll lead you through it. Concentration of atmospheric gases. Father John just went through this. You take a little bubble of air, volume of air, it has 1 million pieces of gas in it. And this is the Earth's atmosphere. The big one is 78% is nitrogen, 21% is oxygen. Argon, of all things, 0.9%. That's 99.9%. That's what we call in the dry atmosphere. Then we go to the greenhouse gases, which are variable. And you would expect that must be carbon dioxide. You would think, but that's what the big everything is about. No, that's water vapor. Water vapor is 1 to 4%, which is between 10 to 40. Here's carbon dioxide over here. It doesn't even show up in the graph. It's just a trace element. Less than 0.05% is what it is, where water vapor is anywhere from 1 to 4%. Sometimes down to 0% in the Arctic and the Antarctic, which are actually deserts. It's so dry. Okay, put it more in perspective. If it's a bubble greenhouse gas, water vapor, this is the average, let's say 20,000 parts per million. There's carbon dioxide, a little yellow dot. That's it. And this puts it in better perspective. Water vapor, on the average, 20,000 parts per million, which is 2% on the average, goes up to 4%. Natural CO2 in the atmosphere is 0.04%. Now, what I'm going to show you on the upcoming slides, fossil fuel, which we call anthropogenic, that's burning fossil fuel and human activity. What do you think that percent is?
Lower.
0.004%. 0.41 of 1%.
Need
And
those
this is
electric
what they
cars.
say is causing global warming.
Yeah, gotta have those electric cars.
It is way too little to cause global warming. And this part you will not find anywhere on the web. It's right here today. So how do we measure carbon dioxide in the atmosphere? This is a big thing. We've only had instruments since 1958, believe it or not. That's it. That's how young the science is. Before that, for the past 1,000 years, they used tree rings as an estimate. And before that, they used ice cores that go back 500,000 years before recorded history. All estimates. And also I'm going to show you fossilized plant leaflets, which is a better source. Okay, to find out how much carbon dioxide was in the atmosphere in the past, they go down to Lake Vostok in Antarctica. The lake is, they drill down in the ice 15,588 feet. That's a lot of ice. The bottom of it is about 1 million years old. So they can get a core sample, what they call a core sample, and what that has, it's trapped air bubbles. And the air bubbles, within the air bubbles are gases. So they can extract the air bubbles and extract the gases to get an estimate of how much carbon dioxide and so forth was in the air over some of the past time. So this is how they estimate it. Only problem is, or one of the problems, is when they estimate it, they take a mean value over a course of 1 to 4,000 years. That's a big long time period. Because 1 to 4,000 years could have, 25 global warming cycles, which isn't good. So this is what they come up with on the ice core samples. Every 120,000 years, we have our interglacial warm periods. In between is our glacial periods. Way back, 400,000 years ago, came out of a glacial period, warmed up. The red line is the temperature. Blue line is carbon dioxide estimates. Then it cooled down. Then close to 338,000 years ago, warmed up again. But look at the carbon dioxide. It followed the rise in temperature by 7 to 10,000 years. So carbon dioxide is not causing the temperature to rise. The rising temperature causes the carbon dioxide to rise. And why is that? Well, when we cool down into the next glacial period, we see the temperature falling like a rock. There's the carbon dioxide way up high still with the temperature falling like a rock. So carbon dioxide doesn't cause global warming. Otherwise, it would have stayed warm. So what happens is we cool down into the glacial period, the colder oceans and the snow cover and land trap and absorb all the carbon dioxide and pull it out of the air. So the carbon dioxide goes down over the course of 60,000 to 80,000 years. Then when we warm up again and the oceans warm up, it's all released again into the atmosphere. And that's why we have rising carbon dioxide. And here we are today, and we're going to look at that, closer look. We're going to just look at the CO2 in the atmosphere right now. These are going back almost 800,000 years ago, where it peaks. You can see the peaks every 120,000 years. Well, in parts per million, this is a line here is 300 parts per million. Ice cores, the CO2 in the ice cores have never been above 300 parts per million. Never, is what they say. But is that true? Because they started recording in 1958, and our CO2 is way up here now, 413. So what's going on here? Is the rise in CO2 since 1850 natural? Is it due to humans or a combination? Remember, ice cores are only approximate values. Now, I'm going to make 2 corrections to the ice core samples, and you won't find this, well, one part you'll find online. And that's the ice core sample they take over a course of 1 to 4,000 years. And it's a mean value is what it is. Anytime you take a mean, you eliminate spikes. And this is what a mean is. Say this is temperatures in some spot in the United States, monthly temperatures, average monthly temperatures. Or in July, the average temperature is 90, average low temperature is 66. Well, that's the average, but if you take the mean value, that's halfway in between. So the mean value, 78, that eliminated your spike of your average temperature is 90. So with a mean of 78, does that mean you've never been to 90 or 100 degrees? Of course not. So that's what happens when you take a big long mean value in the ice core samples, you eliminate the high spike. And that's why it's never been above 300 parts per million. So you take the big long mean, you're really lowering the values by about 17%. So that's my first correction. And a lot of this took thought. I had to ask my advisor here, my helper, as we gathered our thoughts. And my helper says, well, my instincts say, use common sense. And this is what we're doing. We're going to use common sense. And that was the 17% that we're going to add on. Second one is my finding number 2. I showed you where they drill down 15,000 feet to get the ice at any time in the past pre-recorded history. Well, the first 5,000 years of the formation of ice is what they call new ice. Any scientists that study ice cores or have read about the ice cores know that you cannot use the first 5,000 years. You cannot use new ice. The reason is the little air bubbles that get trapped in the ice during the first 5,000 years, they're not locked in place. Gases escape from the air bubbles. And there's research out there that says that you lose about 30 parts per million during the course of the air bubbles getting locked in. So my second correction is we have to add 30 parts per million to the ice cores. So I have 2 corrections on the ice core samples. Add 17% due to the mean value, add 30% due to the lost ppm, parts per million, that should have been in the ice and it's been escaped. So this is what it's going to show. We're going to go to a bar graph. We've had a line graph. Bar graph, and we're going to just show the peaks in the ice core carbon dioxide during the past 500,000 years. And this is what it shows during the last 500,000 years. This is what the ice core sample showed. It was at 280 parts per million, 297, 278, 287, 297, and then we're over here. Now NOAA, which is the National Oceanic and Atmospheric Administration, says this value, the increase since 1850, is all due to burning of fossil fuel. That's what they say. Well, let's add my corrections. First, we're going to add the 17% back onto it due to their taking the mean value and flattening out the spikes. You add that on, we're above 300 parts per million. Then we add the 30 parts per million back on that was escaped back into the atmosphere, and we're way up there. This is where the actual reading should be, is very close to 400 parts per million. And over on the right, the red, that's what NOAA says is all human induced. No, it isn't. I'm saying the rise is 80% natural since 1850, and NOAA And that really lowers the, what NOAA says. Now, am I pulling this out of thin air? Can I back up my claims? Yes, I can. I'm going to show you two examples. First, a research paper came out earlier this year. 3 retired physicists. You have to be retired to do this. If you're at a university, you can't do this. They wrote a paper in a physics journal. And essentially what it comes out to, and this is one thing that blew my socks off, I didn't even know about it, is the red here, this is since 1850, red is the increase that NOAA says due to fossil fuel burning, the increase. Well, what I found out was NOAA records the amount of CO2 in the air on top of the high mountain in Hawaii. They use an infrared spectrometer. But what I didn't know is, yes, it records the amount of CO2, but CO2 has 3 isotopes, 12, 13, and 14. It doesn't separate the isotopes. It only records the amount of CO2 in the atmosphere. So NOAA says, because we've never been above 297 parts per million due to the ice cores, this must be all fossil fuel burning. Well, the 3 physicists, what they did, and so these are assumptions by NOAA, just assumptions, they're guessing. So the 3 physicists, they wrote up a formula to separate the isotopes to determine how much is carbon 12, 13, 14. One of them is, one isotope is natural, another one is fossil fuel. This is what they found on their on their formula. Now that's what NOAA says, the red. This is what the physicists say. You can see all of a sudden the red is changing to green. There's 1900 and 1958, and watch what happens here. Remember, NOAA says that is all due to fossil fuel burning. They say no, it is 80% natural. Just like what I said. And the additional one I'm going to show is using fossilized plant stomata. These are plant leaflets. A plant leaflet has little stomata cells in it. It's like our lungs. We have 2 lungs. The plant stomata can have many lungs in it. If it has a lot of them, that means we didn't have very much carbon dioxide in the air at that time. Needed more lungs to bring in carbon dioxide. If it has very few stomata cells, that means we had a lot of carbon dioxide in the atmosphere, so I didn't need as many lungs. It's just how they bring it in. And so the plant leaflets bring in the carbon dioxide, and gee, their byproduct is oxygen. Can you believe that? So this is what the fossilized plant stomata cells show. And one good thing about this is the fossilized plant leaflets, they can determine it year by year. Not like the ice core samples where they take a mean value over the course of 1,000 to 4,000 years. This is annual, going back 1,100 years. So what this shows is back in 800 AD, the CO2 in the atmosphere is 375 parts per million. But we've been told it's never been above 300. Then it went way down, up, down, up, down, up, down. And in 2010, it was at 375. And if 12 years later, we're probably up around 385 or so. So at that time, most of the scientists poo-pooed this because they said, carbon dioxide doesn't go up and down like that because they're used to using the ice core samples that are very flattened out. Now you take a mean value of the plant stomata CO2, it comes out to 301 parts per million. That's a 1,000-year mean. Ice cores during a 1,000, 4,000 year mean is 297, same thing. So why can't it go up and down, up and down, up and down? That's your global warming cycles, past 6 of them, going back to 950 AD. Overlay the plant stomata CO2 on top of it, lines right up with the global warming and global cooling cycles. That's why it goes up and down. And here we are right now, when we go into global cooling cycle, during the next 40 years, we'll probably see a big drop in the CO2 in the atmosphere. Putting it all together, NOAA says a rise since 1850s, 100% fossil. I say it's 80% natural. The 3 physicists and the plant stomata, we all say it's 80% natural. And this is how we came out with this figure where natural CO2 in the atmosphere is 380 parts per million, 0.04%, but the fossil is 0.004%, 4 1,000,000%. Far too little to be causing climate change. And then they tell you, well, CO2 in the atmosphere is harmful. It's bad for everything. Well, you have to remember when the dinosaurs roamed, way back before recorded history, which was 500 million years ago. Big, enormous animals, big plants. Carbon dioxide was 1,500 parts per million. Oxygen, well, now we're down to 412 parts per million. We're a lot lower. Oxygen, when we had a lot of CO2 in the air, 31%, now we're down to 21%. We're getting oxygen starved because we do not have enough CO2 in the atmosphere. So I'm almost done here. There's our 6 cycles. Global warming cycles past 1,100 years. Next one should come in 2024. Actually, I am done. Yes, sir.
What was Noah's response when y'all came back with, this is really the truth?
Well, I've been talking to the 3 physicists that came out with the formula to dissect the type of CO2 in the atmosphere, and they're getting big blowback from NOAA, big time. They tried to talk the journal into not printing the article. It got printed, so then they asked the journal to retract the article. So NOAA is in fear that if this information gets out, they're in trouble. They know it's true.
That is somewhat the truth.
That's right.
I studied this a lot, especially when my daughter was in 4th grade, because I studied this in high school, and I'm surprised what she was coming up with. The one thing I'd like to ask you a question. When you were talking about the carbon sinks during the cold period and the 400-year lag between the carbon, isn't the ocean the primary carbon sink?
That's the primary thing. The oceans cool off and they extract the carbon dioxide from the atmosphere and store it. It sinks to the bottom of the ocean, it stores it, then the oceans warm up and give it all back. That's just a natural feedback system. And also when you get melting of the ice and snow in the northern latitudes, where you have more permanent snow, and then you get bare ground, that gives off CO2 also. So it's a natural feedback system. So once we start getting more ice, snow and ice cover in the northern latitudes and colder oceans, that would help to drop it, and also the temperature drop, yeah. Just natural feedback. So what happens is NOAA, on their saying it's 100% rise is fossil fuel, they're doing estimates on the lifespan of fossil fuel, lifespan of natural, lifespan of this. They're guessing. But the physicists came out with the actual formula.
Isn't it also true that if you were to actually tell the truth, you wouldn't get your grant money?
That's right. This is a big thing in all the universities. I've talked to some retired heads of departments, and they said when they were in there, first of all, they couldn't talk about natural cycles or climate change, in actual anyway. If they did, they'd either not be able to get a grant or lose grants. So once they retire, they start to write papers, because they're not under the string. Yes, Father Don.
Hey, two questions. One, do you think the scientific community and the political world know the truth?
No. Most of them do not. Politically, the people in the legislatures and all the state governments and even the federal government don't have a clue. They've been brainwashed. I have a friend up in Maine. He talked to the state representatives up there, and they said, well, we need to bring carbon dioxide down to 0. Well, he said, well, you know, plants can't grow if it's below 180 parts per million in the atmosphere. Plants will die. And he said, what? They don't know that. And our senators don't know it. Our representatives, they don't really have a clue what's going on. And actually, a lot of the scientists out there do not know either. They disregard what I'm showing you on the new ice versus old ice. They're locked into the theory that we've never been above 297 parts per million. That's what the ice cores show. But that's an estimate. That's an estimate.
I have two questions. One, is this presentation accessible anywhere? I'd be glad to pay for it.
It is. It's being recorded today.
Okay, so,
Right?
It is, yes.
it is, and so,
Matthew, how do people access this?
This will be on the YouTube channel for Christ the King.
thank you, thank you. And here's my
You're gonna
second.
get banned.
And I do have videos on my website. Go to globalweathercycles.com.
Okay,
globalweathercycles.com. I have several videos on there. If you just Google my name on YouTube, I must have 8 or 10 videos on there. globalweathercycles.com. And when you get on that site, just hit one of the icons, it'll take you over to our principal site. I just use Global Weather Cycles because it's easy to remember than the company, which is Global Weather Oscillations, because no one knows how to spell oscillations.
Right.
okay, here's my second question. As someone that was actually trained as a scientist many years ago, since you're in touch with the universities and professors, is there anybody actually training people how to do proper science anymore?
Not really, because what happens in a university, they get tenured after 10 years.
Yeah.
They get tenured. Well, universities live, the departments live off of federal grants and other grants. And the federal grant system during the past 20 years, they have only put out grants that they write them so they want to be certain answer.
In other words,
You know, they'll write the grant saying, well, we want to know how this relates to human activity causing global change. So this is the grant system they get, and they have to, that's the only grants they can get. So they tell their younger PhDs in the department, you're not tenured. You have to write a paper on this and find out this answer, supply an answer saying humans are doing this. That's where most of this is coming from. It's very skewed. It's very, well, this is one thing I'm trying to get in contact with the DeSantis group and the Trump group. So what I've been telling them is the biggest problem during the past 10, 15 years that has caused this whole problem is the grant system. It has to be redone. That's the root of everything, is the grant system.
Dave, this isn't I'm not being funny, but wish I could be. The scientific and the political community who know you, do they view you as a kook or dangerous?
I think more so dangerous because I showed my presentation to, this isn't being